Hello, I'm Tyler,
And I'm Matt.
and we are very excited to present our senior project on Templeton High School scheduling. So the agenda that we're going to work through today is our topic selection, the problem that Templeton, and then we're going to take you through the process that we went through to come up with our solution, and then talk about our impact and economic analysis and future plans. So we selected this project because of our background in OR. We both took the required OR classes as well as the graduate level OR class, and our background in our learning in IME 312 databasing. And we came to this project through Dr. Freed, as she has children that attend Templeton High School. They have this project and they have this need. And additionally, the scheduling aspect of operations research is the most complex in operations research, and so it's a very challenging project for us to work on. For instance, scheduling compounds difficulty and complexity. So if we're scheduling a school with 10 students and 2 classes, it's a lot different from scheduling a school with 100 students and 20 classes. It just compounds on each other. So the problem that Templeton currently faces is they use an expensive software, scheduling software from Pearson to generate a schedule. And so this expensive software spits out a schedule, and from this base schedule, they need to manually manipulate and readjust to come up with a solution that actually fits their needs. And this takes weeks worth of time. And they can't see the impact that their changes, this manipulation, has on the students, which is a very big problem. So the background research that we did for this project was discussing with Templeton, with their principal, Andrew Cherry, who is very opinionated and feels like there's a lot of need for this, as well as an advisor, Maria, who's been our main point of contact. So we looked into various methods of scheduling in our research, and we selected a new integer linear programming approaches for course timetabling as kind of our main paper to refer to, something that has a similar approach, and we're going to follow that approach with adjusting for our unique problem. And we also looked into the relationship between satisfaction and performance, as we looked at a paper that had talked about employees and their workplace satisfaction correlating to performance, and we think that can carry over into the school and students. So the steps that we took, the process that we took, was after meeting with Templeton, we used the request from the previous year that they were in to develop our OR formulation. So we just took time to come up with our formulation, and this was done through a process through Microsoft Access and Excel. We had to organize and manipulate this raw data to come out with the equations and formulations that we need, and this was a very time-intensive and manual process. And we used Gurobi, which is a powerful solver, to do this because of the large amount of data we're dealing with. As we have over 50,000 variables, we needed a powerful solver as opposed to Microsoft Excel solver to do this. So then our second large step was to create an Access database to streamline this manual process for Templeton to use in the future. So we used Access to make this very easy, and then they can use the results that they get from Access to feed into Gurobi to find their solution. So the variables that we came up with are based on the paper that we referred to before, varied slightly for our project. And so as you can see, we have a student and teacher variables, and the student ID. The student variable has a unique student ID, course ID, and time block. Templeton uses block scheduling with 8 blocks, with only 4 blocks in a day. And so a variable will have unique student ID, course ID, and the 8 time blocks. And teacher is laid out very similarly.
Okay, so we'll look at a more broad definition of all these different constraints we have. So our goal here is to maximize the number of students in the course they want. So basically, if a student gets the course that they requested, it's plus 1 point. Try to get the most points you can. Students, these are the different constraints. Students can only take 1 class per time block. They can only take a class once. Courses need to stay within capacity. Teachers can only teach 1 class per time block. And teachers only teach 3 classes a day. All these except that last one are fairly logical, straightforward constraints. And the last one is just specific to Templeton constraint. So what was our big challenge this recent quarter was how are we going to generate these equations most effectively? So there's a lot that can go wrong when you're, trying to generate, you know, thousands of variables and, arrange these properly into equations. So we want to minimize human error, and as that, sounds, there's a lot of time involved, so we want to try to decrease the amount of time required. What we came up with was an Access database to store the information and then use that information to create these equations. It looks something like this. Those tables are courses. Courses are just a list of the courses. Students is each student with their requests. So each student has 8 requests, 700 students. Now there's 5,600 values in there. Teachers is the teacher, the courses they teach, and then the capacity for each of those courses. So what it does is it draws that information from those tables and arranges them into equations. So if you were to press one of them, you'll end up with something that looks like this, where it's just a lot of equations. And one of the big challenges here was trying to minimize the amount of time between clicking that button and having this show up. As you can imagine, it has to go through all of those values. It takes even a computer a while to do this, a while being a few minutes as opposed to manually being, days. So still pretty effective, but we want to try to get it under 3 minutes each. So to do this, we had to do a lot of streamlining the code, because we first, wrote it to work. We wrote for it to pass on a small sample size, but as we scaled up, it quickly became challenging for it to do some of them. So we had to figure out ways to, not make the computer do as much thinking. We ended up getting all of them under 3 minutes, which was our main goal here, so they can just go through here, copy, paste onto Notepad, and upload that to Groby, and it'll solve it for them and spit out the recommended schedule, more or less. So next, let's look into some of the impact of this. So this should result in increased student satisfaction, which can then lead to increased performance based on that article we read, and also a higher student morale around campus, which is going to be great for the environment there. And it's going to give them more insights into the decisions they make. So that's going to help them explore new potential constraints, like if they have study hall at the same period for all the students, what does that do to, compare to the overall optimum? And it's going to better the information available from board meetings. So now if they want to consider maybe, like I just said, making study hall at the same time, instead of just, debating at a high level, they will be able to see, okay, exactly these many students aren't getting the classes they wanted because we're doing it this time. Is that, enough of a con to outweigh the pro of having study hall at the same time? And they can use more statistics in their evaluations. Economic analysis for Templeton. So increased performance can lead to increased funding for the school, which would be great for them. It can help eliminate some of the need for this software package they use from Pearson. It's a $13,000 a year package they pay for, so they can help cut out some of those costs. And it can decrease the time they need to dedicate to creating these schedules. Right now it's around 6 weeks total. We estimate we can cut that in half, get it down to 3 weeks, which will result in about $4,000 of savings. Now for some future research. For the work on making some tutorial videos to help Templeton through this process and help them learn things when we're not here to do it for them, so they can choose to use this later. We can't do these next two, but we think they could be interesting for future research, future senior projects. Trying to automate the hard constraint formulation. So what this means is right now we're just making this overall equation to bind everything together. But let's say a specific teacher can't teach at a certain time. That's considered a hard constraint, and if we could automate that, that'd be great, because what we're going to do is just instead create videos telling them what to do for that. But if they could automate it, it would take away that chance of human error. And last, we think it would be great to generalize this. So ours is specific to Templeton. If you could cut out what's specific and make it so it's more personalizable for someone else, we could make this for public use, release it to other schools, and let other schools choose to save money with this, which I think could be great, and it's easy enough that other people could do this, no worries, especially with tutorial videos. So thank you for watching. We want to make sure to give a special thanks to Tally and Jesse. They were hugely helpful with this project, and we're looking forward to going to present in Montreal in a week with them.
Thank you.